Welcome to the Sleep and Learn channel. We invite you to listen to interesting scientific facts that will help you fall asleep gently and, at the same time, learn something new. Relax, close your eyes, and let a calm voice guide you into the world of knowledge and sweet sleep. The gentle architecture of our solar system. The solar system is not a chaotic place, even though it may appear vast and wild. In reality, it is a carefully balanced cosmic neighborhood, moving in quiet harmony around a single steady star, the Sun. About 4.6 billion years ago, our solar system began as a calm, rotating cloud of gas and dust. Over time, gravity gently pulled this material together, forming the Sun at the center. Around it, smaller clumps slowly gathered into planets, moons, asteroids, and comets. What may seem dramatic in scale unfolded over millions of years, a slow, patient process shaped by gravity and time. The Sun contains more than 99% of all the mass in the solar system. Its steady light and warmth create the conditions that allow planets to orbit in predictable paths. Each planet follows an elliptical orbit, like a calm track drawn in space. These orbits rarely change, and their rhythm has remained stable for billions of years. The four inner planets, Mercury, Venus, Earth, and Mars, are rocky and compact. Beyond them lies the asteroid belt, a quiet region filled with ancient fragments that never became a planet. Farther out are the gas giants, Jupiter and Saturn, followed by the icy giants, Uranus and Neptune. Even farther still lies a distant realm of icy bodies known as the Kuiper Belt. Despite their differences, all these objects share a common motion. They orbit the Sun in the same general direction. Most also rotate in that same direction, like dancers in a slow cosmic waltz. The solar system is often described in terms of distance. Light from the Sun takes about 8 minutes to reach Earth. That means when we feel sunlight on our skin, we are experiencing energy that left the Sun 8 minutes ago. A small but peaceful reminder of the scale of space. Yet even across these enormous distances, the solar system remains gravitationally connected. The pull of the Sun keeps planets in their paths. Jupiter's gravity helps shield inner planets from many wandering comets. Moons circle their planets with steady devotion. Everything moves, but nothing rushes. If we could step back and observe it from afar, the solar system would not look frantic. It would appear slow and deliberate, a system built not on noise, but on balance. And in that balance, there is something deeply relaxing. The quiet heart of our solar system, the Sun. At the center of our solar system rests a star of steady brilliance, the Sun. Though it appears small in the sky, it is vast beyond easy imagination. If the Sun were hollow, more than 1 million Earths could fit inside it. And yet, from our distance of 150 million kilometers, it feels gentle, a warm presence rising each morning without fail. The Sun is a nearly perfect sphere of glowing plasma. Deep within its core, hydrogen atoms slowly fuse into helium. This process, called nuclear fusion, releases extraordinary amounts of energy. But the energy does not rush outward. It can take thousands, even hundreds of thousands of years for energy created in the core to reach the surface. What finally leaves the Sun as sunlight has already taken a long, patient journey. When that light departs the surface, it travels through space at incredible speed, about 300,000 kilometers per second. Yet even then, it needs 8 minutes to reach Earth. Every sunrise is slightly delayed light from the past. The Sun accounts for more than 99% of the solar system's total mass. Its gravity gently anchors the planets, guiding their orbits with consistency. Without the Sun's steady pull, the planets would drift into deep space. Instead, they move in predictable paths, held in balance by this luminous center. Despite its powerful interior, the Sun behaves with remarkable stability. It shines with almost constant brightness over long periods of time. This steadiness is one reason life has been able to flourish on Earth. A slightly brighter or dimmer star might have created a very different world. The surface of the Sun, called the photosphere, glows at about 5,500 degrees Celsius. Above it lies the corona, an outer atmosphere so hot and delicate that it extends millions of kilometers into space. During a total solar eclipse, the corona becomes visible as a soft, ghostly halo surrounding the darkened Sun. It is one of the most peaceful and awe-inspiring sights in astronomy. The Sun also breathes outward in a gentle stream known as the solar wind. This continuous flow of charged particles travels far beyond the outer planets, shaping a vast bubble around our solar system called the heliosphere. Within this protective region, our planetary family moves together through the Milky Way. Though the Sun will continue shining for about 5 billion more years, it is currently in a calm, middle-aged stage of its life. It is neither young nor near its end. It simply continues, steady, constant, reliable. If we imagine the solar system as a quiet home, the Sun is its hearth, glowing, central, life-giving. It does not shout or flicker wildly. It radiates, and every planet, every moon, every small drifting comet responds to its quiet gravity. The inner worlds: Mercury, Venus, Earth, and Mars. As we drift outward from the steady warmth of the Sun, we encounter the inner planets, 4 small, rocky worlds shaped by heat, time, and gravity. These planets are often called the terrestrial planets, meaning Earth-like, because they share solid surfaces and dense cores. Closest to the Sun is Mercury, a quiet and airless world. Its surface is marked with countless craters, reminders of ancient impacts from long ago. Mercury experiences extreme changes in temperature. During its long daylight, the surface can become intensely hot, while at night it grows deeply cold. And yet, Mercury follows its path around the Sun with remarkable precision, completing one orbit every 88 Earth days, swift and steady in its rhythm. Next comes Venus, often called Earth's twin because of its similar size. But Venus is wrapped in thick clouds of carbon dioxide that trap heat in a powerful greenhouse effect. Beneath its bright cloud cover lies a world of volcanic plains and immense pressure. Venus rotates very slowly and in the opposite direction of most planets. A single day on Venus lasts longer than its year. Despite its harsh surface conditions, from space it appears calm, a pale golden sphere glowing softly in the sunlight. Then we arrive at Earth, our home. Earth is the only known planet with liquid water oceans on its surface. Its atmosphere gently scatters sunlight, creating blue skies and soft sunsets. The Moon orbits faithfully nearby, stabilizing Earth's tilt and contributing to the steady rhythm of tides. Earth's orbit lies within the Sun's habitable zone, where temperatures allow water to remain liquid, a delicate balance that has supported life for billions of years. Beyond Earth lies Mars, often called the Red Planet. Its rusty color comes from iron oxide dust covering its surface. Mars has towering volcanoes and vast canyons, including Olympus Mons, the largest volcano in the solar system. Though today Mars is cold and dry, evidence suggests it once had flowing water long ago. Gentle dust storms now sweep across its plains, reshaping the surface slowly over time. These 4 worlds share similarities, yet each expresses its own quiet personality. All formed from the same early cloud of dust and gas. All orbit the same Sun. But distance and atmospheric differences have shaped them in unique ways. Between Mars and the next region of the solar system lies the asteroid belt, a broad band of rocky remnants that never formed into a planet. These fragments are ancient, preserving clues about the early days of planetary formation. They drift peacefully, following predictable paths around the Sun. The inner solar system is not empty space. It is a region filled with motion, history, and subtle balance. Each orbit, each rotation, continues without hurry. The majestic giants, Jupiter and Saturn. As we travel beyond the quiet belt of asteroids, the solar system begins to feel vast in a new way. The rocky worlds give way to giants, immense planets composed mostly of gas, swirling storms, and deep atmospheres. Here we meet Jupiter and Saturn, the largest planets in our cosmic family. Jupiter is the largest planet in the solar system. More than twice as massive as all the other planets combined, it dominates the outer region with gentle authority. Though it has no solid surface like Earth, Jupiter's thick atmosphere is layered with bands of clouds that circle the planet in soft stripes of cream, orange, and brown. Within these clouds lies the Great Red Spot, a massive storm that has been swirling for over 3 centuries. It is large enough to swallow Earth whole, yet from a distance, it appears almost like a calm brushstroke on a painted sphere. Jupiter rotates quickly, completing one day in less than 10 hours. This rapid spin shapes its clouds into elegant horizontal bands. Jupiter also acts as a quiet guardian of the inner solar system. Its enormous gravity attracts many comets and asteroids, reducing the number that travel toward the inner planets. In this way, Jupiter has likely played a role in protecting Earth over billions of years. Orbiting Jupiter is a remarkable family of moons. Among them are 4 large worlds discovered by Galileo in 1610: Io, Europa, Ganymede, and Callisto. Each is unique. Europa hides a vast ocean beneath its icy crust. Ganymede is the largest moon in the solar system, even larger than the planet Mercury. These moons move in harmonious patterns around Jupiter, forming a miniature solar system of their own. Farther outward lies Saturn, known for its magnificent ring system. Saturn's rings are made of countless particles of ice and rock, ranging in size from tiny grains to mountain-sized fragments. Though they appear solid from afar, the rings are delicate and thin, like cosmic lace encircling the planet. Saturn itself is composed mainly of hydrogen and helium, similar to Jupiter, but it is less dense. In fact, Saturn is so light for its size that, in theory, it could float in an enormous ocean of water. Its atmosphere features soft golden tones and subtle storms that drift quietly through its upper layers. Saturn also has many moons, including Titan, a world with thick clouds and rivers of liquid methane flowing across its surface. Titan's calm, hazy appearance makes it one of the most intriguing bodies in the solar system. These giant planets remind us of scale. They are immense, yet they move with quiet consistency. Their gravity shapes the paths of smaller objects. Their moons orbit faithfully. Their storms swirl, sometimes for centuries. In the outer solar system, distance grows, light softens, and motion slows into a deeper rhythm. And beyond these giants lie even more distant worlds, colder, bluer, and quieter still. In the next part, we will journey to the icy realms of Uranus and Neptune, where sunlight becomes faint and the solar system fades gently into darkness. The distant blue realms, Uranus, Neptune, and the edge of the solar system. Beyond the golden glow of Saturn, sunlight grows softer. Distances stretch wider. The warmth of the sun becomes faint, and the solar system enters a quieter, colder region. Here we find Uranus and Neptune, the icy giants, distant, blue, and serene. Uranus is unique among the planets. It rotates on its side, tilted at an angle of about 98 degrees. Instead of spinning upright like Earth, Uranus rolls along its orbit. This unusual tilt creates extreme seasons. For many years at a time, one pole faces the sun continuously, while the other remains in long darkness. Yet, despite this strange orientation, Uranus moves calmly and predictably in its wide orbit, taking 84 Earth years to complete one journey around the sun. Its color is a soft blue-green, caused by methane in its atmosphere, absorbing red light and reflecting blue. Beneath its upper clouds lies a deep and cold interior, composed of water, ammonia, and methane ices. Though powerful winds move through its atmosphere, from afar, Uranus appears smooth and tranquil, almost like a quiet marble suspended in darkness. Even farther from the sun lies Neptune, the most distant major planet. Neptune shines a deeper blue than Uranus, its color rich and luminous. Though it receives only a small fraction of the sunlight that Earth does, Neptune is surprisingly dynamic. It holds the fastest winds in the solar system, racing through its atmosphere at tremendous speeds. And yet, from a distant viewpoint, Neptune appears peaceful, a calm blue sphere slowly circling the sun once every 165 Earth years. Neptune also hosts a system of moons. The largest, Triton, orbits in the opposite direction of Neptune's rotation, a sign that it may have once been a wandering object captured by Neptune's gravity long ago. Triton's icy surface reflects faint sunlight, glowing softly at the edge of our planetary neighborhood. Beyond Neptune lies the Kuiper Belt, a broad ring of icy bodies left over from the early solar system. These objects are small and distant, moving slowly in the cold outer darkness. Among them are dwarf planets such as Pluto, once considered the ninth planet. Pluto follows an elongated orbit that sometimes brings it closer to the Sun than Neptune, though their paths never collide. Farther still stretches the scattered disk, and, beyond that, the distant Oort cloud, a vast spherical shell of icy fragments that may extend halfway to the nearest stars. These regions are rarely disturbed. Objects there may take thousands or even millions of years to complete a single orbit around the Sun. At this outer boundary, the Sun's influence gradually fades. Its solar wind forms a protective bubble known as the heliosphere. Beyond this boundary lies interstellar space, the quiet realm between stars. The outer solar system feels distant and hushed. Light is dimmer, movement is slower, time stretches longer. And yet, even here, gravity maintains its gentle order. Every world, every fragment of ice, continues its patient orbit around the same steady star. A quiet system in motion. Our place among the stars. When we step back and imagine the solar system as a whole, it becomes something gentle and harmonious. A family of worlds bound together by gravity, light, and time. From the warm brilliance of the sun to the dim icy bodies at the edge of interstellar space, everything moves in quiet coordination. The planets do not wander randomly. Each follows a precise orbit shaped by gravity. These paths are not rigid lines, but graceful ellipses, maintained by the delicate balance between motion and attraction. The same force that draws an apple toward Earth keeps Neptune circling billions of kilometers away. The solar system itself is not standing still. It travels around the center of the Milky Way galaxy at a speed of about 220 kilometers per second. Yet, even at this tremendous velocity, the motion is smooth and steady. One complete orbit around the galaxy takes roughly 230 million Earth years, a galactic year. Since the time of the dinosaurs, the solar system has moved only a small portion along this vast journey. All the planets orbit in nearly the same plane, like coins spinning on a flat table. This shared alignment reflects their common origin in the ancient rotating cloud of gas and dust. Even today, that early harmony remains visible in their orderly motion. Small bodies continue to drift quietly among the planets. Comets trace long, graceful arcs, sometimes returning after centuries. Meteoroids occasionally enter Earth's atmosphere, briefly lighting the sky as shooting stars. These are gentle reminders that the solar system is dynamic, yet rarely chaotic. There is also an invisible structure holding it together: gravity. It is not loud or visible, but it shapes every orbit and every rotation. Without gravity's steady influence, there would be no predictable sunrise, no seasons, no tides. From Earth, we often look outward with curiosity, sending spacecraft across millions and even billions of kilometers. These missions move slowly, taking years to reach distant planets. And yet, compared to the age of the solar system, even decades are brief moments. In the vastness of space, our solar system is only one of countless planetary systems. Around distant stars, other worlds orbit quietly, following their own steady rhythms. What we observe here, balance, motion, and stability, may be common throughout the galaxy. And yet this system is also uniquely ours. Here, on a small blue planet orbiting an ordinary star, life has had time to grow and reflect. We exist within a structure shaped by gravity and illuminated by steady sunlight. We live in a place where the cosmic dance has remained stable long enough for oceans, forests, and consciousness to appear. When viewed from afar, the solar system is not noisy or frantic. It is patient. It is ordered. It is continuous. The sun will continue to shine for billions of years. The planets will continue their quiet revolutions. The outer icy bodies will drift in distant cold. And through it all, our solar system will remain what it has always been: a calm island of motion, traveling together through the stars. Time, silence, and the long future of our solar system. The solar system is not only a structure of space, it is also a story of time. Every orbit marks a year, every rotation marks a day, every slow revolution around the galaxy marks an age beyond ordinary imagination. On Earth, we measure time in seconds and seasons, but in the solar system, time stretches outward into millions and billions of years. Mercury completes an orbit in just 88 Earth days. Neptune takes 165 Earth years to circle the Sun once. And the Sun itself will continue shining for about 5 billion more years. A span so vast that all of recorded human history occupies only a thin fraction of a single moment. The Sun is currently in a stable phase of its life, quietly converting hydrogen into helium in its core. This stage, known as the main sequence, is one of balance. The outward pressure of fusion gently counters the inward pull of gravity. For billions of years, this equilibrium has held steady. But even stars evolve. Far in the future, when hydrogen in the Sun's core becomes scarce, it will slowly expand into a red giant. Its outer layers will stretch outward, reaching far beyond its current size. The inner planets will be transformed by this change. Eventually, the Sun will shed its outer layers, leaving behind a small, dense core known as a white dwarf, a faint ember of what was once a bright star. Yet this transformation is unimaginably distant. For now, the solar system remains in a long, quiet middle chapter. The planets will continue their orbits. The moons will circle faithfully. The icy bodies of the Kuiper belt will drift in cold darkness. Even small gravitational interactions between planets, subtle tugs over millions of years, unfold gradually, shaping orbits with gentle precision. The solar system also carries a record of its past. Ancient craters on Mercury and the Moon preserve the memory of early impacts. Meteorites that fall to Earth are fragments of primordial material, older than our planet itself. In their mineral structures, they carry the chemistry of the young solar system. Silence is one of the most profound features of space. Without air, sound does not travel between the planets. Storms may swirl on Jupiter and winds may race across Neptune, but the vast distances between worlds remain silent. Motion exists without noise. Even sunlight moves quietly. When we look at the night sky, we are seeing the solar system from within, orbiting a steady star surrounded by darkness and distant starlight. Our world is part of a long continuum, shaped by gravity and guided by time. The solar system has endured collisions, migrations, and changes in its earliest days. Now, it rests in a long era of stability. That stability has allowed life to emerge, to think, to observe. In this vast and patient system, we are both small and deeply connected. We live inside a structure that is older than mountains, older than oceans, older than life itself. And as it moves quietly through the Milky Way, the solar system continues its slow, elegant journey, not rushing, not pausing, simply unfolding across time. A small blue world in a vast, gentle universe. As we come to the end of our quiet journey, we return to a simple image, a small blue planet orbiting an ordinary star. From a distance, Earth is only a pale sphere of light, suspended in darkness. It is one world among many, moving in harmony within a vast and steady system. The solar system does not rush. It does not tremble in chaos. It turns. The sun rises and sets because Earth rotates with calm precision. The seasons change because our planet tilts gently as it circles its star. The moon glides across the night sky in predictable rhythm, guiding the tides. Even distant Neptune follows its path faithfully, though its year lasts longer than a human lifetime. All of this motion happens quietly. If we could step far beyond the outer planets and look back, we would see a faint golden glow marking the sun, surrounded by tiny points of reflected light, the planets. Beyond that, only the soft shimmer of distant stars. The solar system would appear peaceful, almost still, though it is always moving. There is comfort in this stability. For billions of years, gravity has held these worlds together. The same physical laws that shaped the earliest dust clouds continue to guide each orbit today. Nothing here is accidental or hurried. Everything follows the gentle mathematics of motion. And within this structure, life has emerged. On Earth, oceans rise and fall, forests grow, winds travel across continents. Human beings look up at the night sky and wonder. We send instruments beyond our planet, crossing millions of kilometers to photograph distant giants and icy moons. Through these efforts, we slowly come to understand the quiet order that surrounds us. The solar system teaches patience. Planets take years, even centuries, to complete their journeys. Comets return after long absences. Stars evolve over billions of years. In comparison, our own lives are brief, but they unfold within something ancient and enduring. When you look at the night sky, you are not seeing randomness. You are witnessing structure, a balanced system that has remained stable long enough for consciousness to arise and observe it. The sun will continue shining tomorrow. Earth will complete another rotation. The outer planets will drift along their immense paths, and the solar system will keep traveling around the Milky Way, quietly and without urgency. In this vast universe, we live within a place of remarkable harmony. A steady star, a family of worlds, a small blue planet where life can pause, breathe, and look upward. And perhaps that is the most relaxing fact of all.